Fridge day on the bus. We spent the majority of the day unplugging the power, the 12 volt and the propane from the fridge, and then getting out of its hole, and then getting it and trying to get out of the bus. First attempt failed. The door kept getting stuck. It's just barely wide enough to fit. So the first attempt failed, so we went back and then we took off the doors, took off the hinges, took everything off the top, and then we were barely able to squeeze it out, got it back around to the front yard, or to the front of the carport, and then put all the doors, the hinges, everything back on, and then cleaned it all completely. So this is Dometic RM2820. It's a little bit older fridge. I think it's now discontinued, but it's about 8 cubic feet. We are a little bit worried about the capacity because we're used to a residential style fridge. We're also worried about, if we put a residential style fridge, if we can even get it to fit, what kind of power does it take? So we've heard that they are pretty power hungry and that these are much more efficient. So we got one of these. It's called a kilowatt. It measures how much energy is being used by a device on 110 volts AC. So we've got that, and I've also rigged up something to measure how many amps are being drawn from the 12 volts. So the way these work is there's a 12 volt system that powers sort of the brains of the refrigerator, the circuitry and stuff like that, and then the cooling actually happens from the 110 volt AC or from propane if you're not plugged into shore power or you don't have access to an inverter. So we are pretty sure that this works because it started cooling down, but we wanted to make sure that it worked, and we wanted to get it all cleaned out and stuff like that and test it, and we're going to run it on this to see how much power that the fridge consumes. So I've rigged up a thing to show you how much power that it draws off of the 12 volts, and then we'll measure that as well so that we know the total, kind of the total power output from the fridge, and then we can then measure it against sort of, we have a residential style fridge in our house, and we can do a comparison to see how much power each one uses. The back of the fridge, so we've hooked up our voltmeter here to read amps AC. This is a PC power supply, and so we'll go ahead and power that on. And so as you can see, there's no voltage going through right now because I haven't turned the fridge on. But once I turn the fridge on, since there's no AC plugged in, we haven't plugged in our AC yet, what it should do is it should power on, and then it'll show us how many amps it's drawing at 12 volts. And then it should start to sort of click, trying to ignite the propane. So let's turn it on. So there's the click. So we see it draws about, it looks like half an amp. So that's about 6 watts of power. So we can hear now that it's trying to light the gas. It turned on the gas. So we'll turn it off. So now we know from that little experiment that we are drawing about half an amp at 12 volts, which is not very much at all. So like I said, it's about 6 watts. So that is almost nothing. So we'll hook this up more permanently. I'll remove my voltmeter, and then we'll hook up this guy and see, first of all, if this is working, if it's cooling, and then we'll see how much power it takes. We'll also try to use the fridge. We'll open it and stuff like that just to kind of make it more realistic and stuff like that. So anyway, I'll hook this up and then we'll be back. We're back. I've hooked this up more permanently now. I've taken my voltage meter out and just kind of hooked it directly to the 12 volts in the back. This is still our PC power supply, supplying the 12 volts. This is our power meter, and I'll go ahead and reset it. So that will reset all the counters and everything on there back to 0. So we can see that we use no kilowatt hours and no elapsed time. So we'll go ahead and plug this in, just right here. It's nice and easy. We just plug it in like this, and we see that it's reading 122 volts. And we'll go ahead and power the PC power supply on, which should be fine. Can you see that? Uh-huh. So we'll go ahead and turn the fridge on, and now it should detect that it's on AC. Okay, now it's on AC. Okay. So now it's on AC. We should see it drawing some watts. Not sure how to work this. All right, so we're at about 350 watts or so. It's cooling down. This will calculate how much over time, kilowatt hours. You see it's about can you see that? It's about 2.85 amps that it's drawing right now at 120 volts. So it's, yeah, so about 300, so the watts should be right. So, so we should, 345 watts. So we'll see how many kilowatt hours this takes over, say, a 24-hour period or a 48-hour period, but we'll let it cool down, and then we'll just keep gathering measurements on this thing and see what kind of power it takes. So far, 350 watts isn't much, and then we can compare it to our residential fridge and see kind of what the difference is. An update on this fridge. So we took it out about a week and a day ago, it turns out, and we've just been running it in the garage here for the last about a week, and we hooked up this little thermometer. There's a little wire that goes inside the door that tells us kind of what temperature it's staying at, and you can see, I don't know if you can see that, but it's at about 35 degrees, which is about right. So we read like, oh, what should it be? And we've actually set the cold, we had to bring it down to 3 because it was actually getting to where it was pretty close to freezing in the bottom section. And in the top section, it gets really cold. In there, it'll go below 0. So, the refrigerator is actually working really well. We didn't use it like we said we would. We said we were going to try to maybe put some groceries in there and take things back and forth because it was just using a lot of power. It was, even just when it first started up, it was using about 350 watts. And that's quite a bit. Over like the whole day, it ended up being somewhere around 5 kilowatt hours a day. So we have the readings now, so it's still actually running. And we'll do some math here, but we've got it's been 189 hours, and it has used 38.4 kilowatt hours in that 189 hours. So we're going to do a little bit of math and see what that comes out to. But what we've also discovered is that for about the same size fridge in one that's all electric, they're using less than 1 kilowatt hour a day. So that seems like a better option for us. We're probably always going to run our inverter. We bought a pretty large battery, so we're probably going to run our inverter all the time. We're also considering 12-volt marine fridges, so that's still kind of playing back and forth, but we've kind of decided that this fridge is too inefficient, so we are now looking at other options. All right, so we're concluding our fridge testing. We've left this fridge plugged in for a long time, mostly because we kind of forgot about it and started doing other things. But so it's used 71.93 kilowatt hours over 831 hours. Can you see that?
Yep.
So it's used 831, and it's 71.93 kilowatt hours. So we did the math, and it comes out to about just right at 2 kilowatt hours per day, and that's over a few weeks. So it's about 2 to 2.5 times more efficient than that little tiny fridge, the RV fridge that we tested before. So that one was using, I think, just over 5 kilowatt hours. I'll check the math on all that stuff too. So this fridge is about twice as efficient, and then they make smaller ones than this that are about twice again as efficient as this. So that use less than 1 kilowatt hour per day. So that should be pretty good on our batteries. So it'll give us less concern since we're at about 23 or 22 kilowatt hours in our batteries. That should give us enough for about 20 days or so if we're conservative without plugging in. So anyway, we also want to use this to test. We got our AC running, so we want to use this kilowatt to test, so we wanted to conclude this test. So that's where this is at. We're pretty sure now that we're going to get just a smaller residential fridge that we're going to put in the RV. Yes, it doesn't use propane, but it's also probably going to be about 6 times more efficient, maybe 5 times more efficient. So I think that's the route we're going to go.